All right, in this video, we're going to be taking a closer look at primary storage. So, Cambridge says, when you see the word primary storage, you need to understand exactly what is meant. So you need to basically be able to describe what it is, why we need it, and what it does. So to look at this, we first need to look at the fact that there are two types of storage in a computer. All right, two types of memory. Secondary and primary. Secondary we'll look at closer in the next video, but basically it is where all your files and documents are stored. So if you are working on a piece of work and you click save, it goes into your secondary storage and then you can get it again later. All right, so that's secondary storage. Let's have a look closer at primary. So what is primary storage? Now, if you think back to the fetch, decode, execute cycle. If you can't remember the fetch, decode, execute cycle and all of the registers that are used within it, go back and look at the fetch, decode, execute cycle video and it'll explain everything. Then you can come back to this one. So you have your CPU. Your CPU is full of registers that you use to run instructions. If you can't remember the registers, remember, go back and look at the video about registers and the fetch, decode, execute cycle. But all of the things that the CPU is running are stored in something called RAM, random access memory. Now, the random access memory holds instructions for programs that you are using currently. So if you're not using it, it's not there. So if it's not there, where is it? Well, it's in your hard drive, which is secondary storage, so I won't talk too much about this, but imagine I have PowerPoint and I want to use PowerPoint, so I go up and I click on PowerPoint on my computer. What happens is the instructions to run PowerPoint are then put into my RAM, and now my CPU can directly communicate with my RAM to get the instructions out of it. And that's how it works. So because the CPU can directly communicate and directly get instructions from the RAM, that is why we call it primary storage, because it's the primary place or primarily where the CPU looks for instructions. It's directly connected to it, which is why it runs so fast. But RAM is what we call volatile, and that means that when you turn the power off, you lose all of the instructions that are inside there. Your hard drive does not lose anything when the power's lost. Now, as far as primary storage goes, there are two different types. You have RAM and you have ROM. We'll look at RAM first. So RAM, like I said before, stands for random access memory. And it's basically where all of the instructions that you are currently using are stored. So this means that if you've got a big program that needs lots of instructions like Blender or something like that, there's lots of instructions stored in there, and means you need lots of RAM to run it. That's why you need a reasonably expensive and capable computer to run something like Blender. So all of the instructions go in there and the CPU connects to it and it runs it straight away. Once you're finished with it, it will put it back into your hard drive because it doesn't need it. So why keep it in there if it doesn't need it? That's just a waste of space. This is why you should always close programs down on your computer that you're not using, because it will help your computer run other things faster. And then we have ROM. ROM stands for read only memory. Now this is a tiny chip on your computer and it kind of looks a bit like a little insect. It's like a chip and it has multiple connectors that connected to the motherboard coming off the side, and it kind of makes it look like a little bug. And this holds inside of it, inside of here, it holds the BIOS. It stands for basic input output. Okay, and then you sometimes might see this called the bootstrap. And this is the code that your computer needs to find the operating system when it first turns on. So when you switch your computer on, the CPU, first thing it does is goes to find the ROM, and it gets the instructions out of the ROM and it puts them in the RAM so they can then be carried out. And this will just tell the computer, oh, the operating system's here, go and get it, go into the operating system, open it up, load all of your input and output devices that make your computer work. Now, like the name suggests, read only. This means you can't change it. You can only read from it. This is very important because if you were to change it and you did something wrong, your computer would not be able to load your operating system up, which would mean your computer would not work. So it's set at the manufacturing level and you can't change it unless you have special software. But I would advise staying well away from it because you really run the risk of making your computer unusable if you use it. Or change it, I should say. So let's have a look at the differences between RAM and ROM, because this is something that Cambridge might ask you in the exam. Let's just change the colour so you can see it better. So number one, RAM is volatile. This means that when you turn the power off, all of the contents disappear. ROM is non-volatile. This means that when you turn the computer off, the ROM stays as it is. RAM stores the data that is currently being used by your computer. Anything you're using is inside of the RAM. ROM just stores the bootstrap, or if you want to call it the BIOS instructions that tell your computer how to start up. RAM is constantly being changed when the CPU is doing its processing. So what is inside of the RAM is constantly changing. These are instructions, they're programming instructions, so it's changing from one to the other. Depending what you do in your program will depend on what the program does next, so it's constantly changing. But the contents of ROM are fixed. You can't change them ever. Yeah, they're just there to help the computer start up or make the computer start up. That's why you can't change them. And I do say in some, I should put this on here, in some, or maybe most computers, you can change the amount of RAM. So it means you can increase it if you need to. If you start working on a program that takes lots of RAM or lots of memory instructions, you can make it bigger. But obviously in modern day computers, the thin ultrabooks you have, a lot of Mac computers, the Mac laptops, you can't change the size of RAM because they're fixed onto the hard drive. But the technology itself allows you to increase it. It's just some computer manufacturers stop you from doing that. Whereas ROM, you can't change it, all right? Or at least not easily. You need special software, you need special skills to do it. Whereas RAM, you can basically just take it out and put it in and it should plug and play no problem. Okay, so let's have a quick summary and I'll just make this a little bit smaller. So if you need to, you can screenshot it. And I'll try and move my pens out the way so you can do that. Yeah. So let's have a look. There. So you've got your primary storage. It is basically referring to your RAM and your ROM. It's called primary storage because you can access it directly from the CPU. Right, so it directly accesses from the CPU. It's all there. It plays its direct connection. Right? A direct wire inside the computer connects it, which makes it run fast. Whereas secondary storage is a lot slower. Okay, and then you finally have the two different types of primary storage: RAM, random access memory, and ROM, read-only memory. RAM for the instructions that you currently have in your computer. ROM is so your computer can start up and find its operating system and all its input and output devices. It holds the BIOS or the bootstrap. They're the same thing. It's just some people call it bootstrap, some people will call it BIOS. And there you have it. Primary storage. If you need to screenshot that, you can do it now.